So the sides are the same, and this is x rad 2. Okay. So 30, 60, 90 triangle. Opposite the 30 is x. Opposite the 60 is x rad 3. Opposite the 90 is 2x. So then going down here, if I'm given certain portions, if this is 45 and this is 90, then obviously this must be 45. So then 45, 45, 90 triangles are isosceles triangles. And then this side, this is 6, this must be 6. And opposite the 90 degrees is x rad 2, 6 rad 2. All right, so you can do 18 and 19. Let's do some 30, 60, 90. So 30, 60, 90, opposite the 30 is my initial value. Opposite the 90 is 2 double this. So this is 24. This must be 60 degrees. If this is my initial value, this will be 12 rad 3. Okay, 12 rad 3 is that. This line up here. This value is 24. Yep.
On the test, are we gonna answer like 12 rad 3 or do you want to like simplify it?
Oh, square root answers. Yeah. And remember, it's multiple choice. So then if all the options will be there, just pick one, whichever one. Yeah.
Do 18.
Huh?
Can you do 18?
Oh yeah, 18 is harder. Because opposite the 90 is x rad 2. I'm not a fan of these x's and y's. It's confusing. So x rad 2 equals rad 14. So I'm dividing by radical 2. And did you know that you can do this? Like that? You can put it together under 1 square root. Rad 7. And they're both, since it's isosceles, so that's good. That was a smart one to pick. Okay, so you did 20. I'll keep going. Turn the page. So when you guys are taking the final though, aren't you gonna want a paper copy in front of you to find it quickly? I have to open up a document. Do you want a paper copy? No?
No, it's because I already started on the page.
Okay. All right, sine, cosine, and tangent. Trigonometry. We did a little bit of this last week. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So sine of W is angle W right here. I do the opposite side over the hypotenuse, 24 over 30. Always reduce 6/4. Okay. Cosine of W, adjacent. The hypotenuse has its own value always. Adjacent means right next to. 18/30. So I guess 6 again. 3/5. Tangent, opposite over adjacent. Opposite over adjacent, 24/18. 4/3.
Wait, so how do you determine what is that?
Well, you look at, since it's asking me for W, I'm at angle W. This is opposite, because see how it's like opposite the angle? Adjacent means like right next door. Adjacent. The hypotenuse is always the longest side and the 90, opposite the 90-degree angle. So then I just give you a random triangle and you have to figure out what to do about it. So 25, we'll do 25. We're only going to 32. Probably do more, but okay. I have 48 degrees. Then I say, do I have the adjacent? Do I have the opposite? Do I have the hypotenuse? And you have to figure out from here, well, should I use sine or cosine or tangent? So 48, what do I have in this triangle? Do I have the hypotenuse? Do I have the opposite? Do I have the adjacent? What do I have?
You have the adjacent and the opposite.
This is adjacent and this is opposite. Very good. What's adjacent and opposite? So I'm going to use tangent. After the word, the sine word, cosine word, tangent word, you put the degree measure. Tangent of 48 equals opposite x over adjacent 7. And then this is you using your calculator. And to solve for x, I multiply both sides by 7. Tangent 48. So you just do that in your calculator. Round to the nearest tenth, 7.8. That's how long the side is. It's 7.8 long. So that's 25. I'm scrolling. Trigonometry is something that you're going to use all the way until your senior year. It's in every single class. Next year in Algebra 2, and then you'll have it in pre-calculus, and then you'll have it in calculus. So down here, let's see. All right, 26. I have 68 degrees. I have the hypotenuse. Now, this would be the opposite side. I don't have the opposite side. This then makes this the adjacent. So I have adjacent and hypotenuse. What's that?
Cosine.
Cosine. After the word cosine goes the degree measure. Always, always. adjacent over hypotenuse. And I wanted to do this one specifically because I've got the trick that I've told you about. When the unknown is in the denominator, you switch like that. So this is gonna be x equals. And you put the cosine 68 in the denominator. So that's what goes in your calculator. (22) divided by cosine 68. So 58 point, round to the nearest tenth, 7. 58.7. Okay, let's do 31.
Miss Grant,
Yep.
how do you input it into the calculator for like 28? Do you use second and then the sine, cosine?
No,
and
don't do
tangent?
second. Don't do second. You put, well, mine looks like this. I can show you really quick on my. This is what mine looked like on my calculator. So is that, you know what I could also do if this didn't work for me? Cosine 68 times 22. I could do cosine 68 and then do times 22. Whoa, no, 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 no. Nope, 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 nope. Cosine,
Oh,
What
I
was it
meant when
dividing?
there's like no angle inside the triangle.
oh, what
Like for
number is
20
that?
Like 28, 29, and 30. where
Let's
it's
do
just
one of those
X.
then. Okay. Yeah, we need to do one of those. Thank you for pointing that out. When you don't know the angle, that's where I'm gonna do, so I'll do 29. I am given the opposite and I'm given the hypotenuse. So opposite and hypotenuse is sine, correct? Sine of, I don't know how large the angle is, equals opposite over hypotenuse. This, yes, you do. Second sine, because this gives you the sine inverse. When you don't know an angle measure, you use the inverse. That's the second function. It's above the word sine. It says sine to the -1 power. Then I do 5 divided by 16. Should second sine 5 divided by 16. Yep. 18.2, the angle measure. So the angle is 18.2 degrees. And I just rounded to the nearest 10th place. All right. The angle of elevation, that's me looking up at something. From a buoy in the water to the top of a lighthouse is 68 degrees. So I'm gonna do a picture because otherwise. So I don't know if you got this, but sine, cosine, and tangent are always in geometry right triangles. It has to be right triangle for geometry purposes. We did some advanced trigonometry with like law of sines and law of cosines, but for this basic trig, it's always right angles, right triangles. If the buoy is 300 feet from the base of the lighthouse, here's the buoy in the water, whatever it looks like, I don't know. Here's the lighthouse. 300 feet from the base of the lighthouse, find the height. Okay. I've got opposite and adjacent. I don't have the hypotenuse. What's opposite and adjacent? Yep. Tangent 68 equals opposite over adjacent. Nope, multiply by 300 both sides. And that goes in your calculator. 300 times tangent 68. 700. I mean, lighthouses are extremely tall, extremely tall. It has to be tall because the light on top emits the in a circular motion to tell the boats like, hey, you're getting close to land. Okay, they're all on the East Coast. I don't know, maybe Washington or Oregon have some, maybe, probably. Lighthouses are very important. Okay. All right. So what I'm going to do is I'm also going to tell you guys where, because on, yeah, I'm going to give you these problems today are your homework. So I had 17 through 32, but I'm also going to post on the review some of those Go Formative on the online Go Formative. There are some problems that we need to do as well. So I'm going to stop the recording, first of all. Yesterday I forgot to press stop for like 10 minutes after.